Relative motion is just another method of applying vector addition. So in order to solve this problem, I would recommend creating a legend first. All right, so we're going to assign each of the frames of reference a letter. So the first thing we're going to assign is the ball. We're going to give it the letter B. And D is going to be for the dock. C is going to be the child. R is going to be for the RV. And F is going to be for the ferry. So what do we ultimately want here? What we want is we want to know what is the velocity of the ball with respect to the dock. That's what we want. And what we have is a series of velocities with respect to a different frame to help us build this. So what I like to do is I like to order them. The first thing I look for is, okay, I want to know what the velocity of the ball is with respect to the child, because that's the way the question gave me this value. Now you'll note that B is the starting variable here and B is the starting variable here. That is no accident, and I'll show you why in a minute. The next thing we add to this is the velocity of the child with respect to the RV. Now that was also given in the question. Now I put these next to each other because you'll notice that there's a C here and a C here. The next thing I'm going to add is the velocity of the RV with respect to the ferry. And then finally I'm going to add the velocity of the ferry with respect to the dock. Now you'll notice that all of the letters have a neighboring letter that are the same except for the D and the B. So, and you'll notice that the B and the D are over here, so they're kind of ordered in a sense so that the last letter of the last vector is the last letter here in the subscript. So now it's just adding vectors. So in this question there was one vector that was going in a two-dimensional way and the other vectors were all going north and south. So let's start off with our x-axis. And what I'm going to do is I'm just going to rewrite this, but put another subscript here. Make it a little bit more confusing. And just to signify that all of these vectors, this is for the x component of the vectors, or the component that's going in the east or west direction. Now if you read the question again, the only vector that has an east-west component is the first one, the ball with respect to the child. And if you recall from how to break up a vector into its components, you should remember that this is the horizontal component of that vector. The other vectors, so the child with respect to the RB, that's 0 in the x-axis. Similarly, there's no east-west component for the RV with respect to the ferry. And similarly, there's no east-west component for the ferry with respect to the dock. So that leaves us with 10 cos 20, which works out to be 9.397 meters per second east. Now let's do the y-axis. For the y-axis, we're going to restate all of this. But now I'm going to have a y subscript. So this time things are a little bit more interesting. Here, this is going to be 10 sine 20 because the ball has a north component to it as well. The child is running south with respect to the RV, so we make this negative to indicate that that's happening. The RV is going north with respect to the ferry, and the ferry is going south with respect to the dock. So when you add all these up, you get negative 0.08 meters per second north. So from someone's point of view, on the dock, if they could see through the boat as if it was made of glass, they would see that the ball has eastward motion of 9.4-ish meters per second east, and a northward motion of negative 0.08 meters per second, or south. So this ball looks mainly like it's going going to the east. So we can just finish this off by, we'll take the Pythagorean theorem of these two numbers. So the Pythagorean theorem is VBD is equal to 9.4 squared plus 0.08 squared, and that works out to be 9.4. And when we want to find the angle, we take the inverse tan of the y over the x, so this will be 0.08 over 9.4, and that works out to be 0.5 degrees. So our conclusion, put it over here, therefore, the ball with respect to the dock is going 9.4 meters per second, and it's east half a degree south, because it's negative there. Now, for the second part of the question, we can actually reuse a lot of our what we've done. So let's just back up a bit here. And we'll just delete this stuff here. Now, the second part of the question said, what is the velocity of the ball with respect to someone who's on the boat? So we don't need this part right here. This part can go away. And similarly, that part belonged to it. So that doesn't change this number at all because that was just adding 0. For the y-axis, though, we have a bit of a change because the ferry was going south, and so now we can ignore that frame of reference because the observer is on it. And that changes this number. And that number becomes 9.92 meters per second north. And if we work out the Pythagorean theorem for that, so 9.4 squared plus 9.9 squared, that works out to about 13.7. And if we calculate the angle, which is 9.9 over 9.4, that works out to be about 47 degrees. So now we have, for somebody on the boat, they see something completely different. They see the ball is moving, it's moving faster, and it's moving more on an angle. So from the frame of reference, of the ferry. The ball is moving.